All right. Hello. Good morning. Uh, so I wanted to do a session because, I've been trying to communicate and discuss like agents, and it's very difficult to kind of get a conceptual idea of how an agent actually works and should work because it's very much focused on the LLM part of it, which is of course important. Like you can't really do agents without an LLM, but there's so much more that needs to come into play to actually make an agent a coding agent. And but I found a way which is kind of obvious in retrospect. A really good way to discuss agents is to think user stories. Because let's see here, we're gonna draw. Hello, there we go. So what if you have a user story, for example, and one thing is implementing like a new project, but we're going to think about this as making a change to an existing project because that's like more complicated, and there's like just another factor to take into account discussing it. So what if you have a user story like, as a user I want to log in with my Google account and see my tasks or whatever. Let's see, we can make this Google account and see my tasks. So what's great about the user story is that they are typically ambiguous. It doesn't say anything about how to, like, what kind of dependency or service would you use to log in with Google. So they're very ambiguous, which is a big problem or a big challenge of making agents work. But it also has a description of, so it has a description of what you want to be implemented, but it also has a description of how it should work. So you can use the same, like, short, as a user, I want to log in with my Google account and see my task, as a validation step, right? Which is just as important for an agent to work. It's that you kind of when you think about an LLM, you don't consider ambiguity. You just think that how good is it at writing code? But it also needs to translate ambiguous things into the outcome. So what I mean to say is that with this user story, which is quite ambiguous, there has to be a transformation into something that's way less ambiguous. Like, there has to be a very specific dependency used, probably. Maybe the project already has a dependency which should implement this Google authentication. The question is, where should it be implemented? How should the UI look like? Does the project have a design system? How are components composed together? There's a lot of things going on there. And where was I going with this? Yeah, anyways. And then yeah, the flip side of that, like, it will try to implement this, and yeah, and there's like a very broad range of outcomes, right? So you have to narrow down the possible outcomes based on the information from the project you're applying this prompt to. And then it needs to validate that this actually works. And there's a lot of challenges here with something as simple as this. It's like, okay, how will this agent be able to run your dev server? How does it know? We're going to dive into all the details here. But how does it know how to run your dev server? How the hell does an agent sign in with a Google account? Should it have its own account? Should it have access to your account as an engineer? Shouldn't it use Google? Should it rely on some other authentication mechanism? And even that, how would it actually interact with your app to do the authentication flow as a user? And how would it validate that it actually sees the tasks? Because there might not be any tasks there. Should it then be able to understand that it should add a task to verify that? Like there's so many questions to be answered here. But that's what I like about the user story. It kind of surfaces all these questions you need to ask and try to answer them. So I thought we could try to do that. So there's two things we want to do. We want to dive into, let's see. Oh, can I make this bigger? Oh, look at that. Let's zoom out a little bit more. And then how to implement. And then we have how to, validate. This is a medium text. So I think we're just gonna do a little ramble here and try to kind of figure out what would it take for an agent conceptually to actually implement this in an existing project. So maybe we should just do a list here. I would like to have this as a user. I want to log in with my Google account and see me tasks. My tasks. See me tasks. Is that like which dialect is that? Yeah, I don't know. Let's see how to implement. It would be nice to kind of have the user story here. Whatever. Okay, so how, like, if we think about this as at a high level, how would you be able as an agent to figure out how to do this? So the question is, there are two approaches to this, I think. One is to iterate with the user to reduce. So how to implement, we have to mention reduce ambiguity here. I haven't really thought about how I want to approach this. So how to implement, there's like a step of reducing ambiguity. Let's see. And there are like two ways to do that. Which is to discuss with the user. Like imagine you're an engineer that's stating this user story. So the LLM can like start asking you questions to kind of enhance that user story into something it can actually implement. So that would be a human conversation or engineer, let's call it engineer conversation, or context enhancement. Let's see. So what do I mean? So we have to reduce ambiguity. Reduce ambiguity. You have to do that first. There's no reason to write any code with this prompt, right? It doesn't make, like, that's the thing that I feel often is forgotten. Is like if you have a prompt like this, that you can send it to an LLM. Like this is the thing. You can send this prompt to an LLM and ask it to write code for this. And you can get a lot of good examples of code for this, like how to implement like Google Authenticity. But since we're running in a project, we can also take information from the project to reduce that ambiguity. So we're gonna say, no, we're not gonna have. You have to excuse me, I haven't thought this through. So we're not gonna depend on the engineer conversation. This is the kind of the thing. Let's even call it. Oh, come on. You'll have to excuse me for just a minute. I'm gonna jump a lot here in the beginning, but then I'm gonna start like summarizing, so we kind of align on the mental image here. So we're gonna have an autonomous agent. Okay, so since we want an autonomous agent to actually handle this, let's make that a nice... We shouldn't have a conversation. Like, ideally, we don't want to have a conversation with the engineer. That's kind of the whole point of an autonomous agent, is to be able to handle quite ambiguous statements, because it will understand, based on the project, how to perform that task or resolve that prompt. So then the question becomes, okay, it can use context enhancement to resolve this prompt. And what I mean by context enhancement, and context enhancement has nothing to do with the LLM itself, right? And this is where I think the conversation falls short on agents. It's like there's so much talk about what these LLMs are able to do to become good agents. Like, as long as they have better models, they will be able to do fantastic things. They need to do planning. But I don't think that is the problem. I think you can actually... My intuition, based on like playing around with this, is that you need tools. You don't need a better model. Like, if the model is able to write code, the point is just to make it write correct code in the context of the project. Yeah, that's what I mean. And like GPT-4, Omni, even GPT 3.5 is really good at writing code. It's just that it doesn't know what code to write. It doesn't know the context. So we have to enhance its... maybe I shouldn't call it enhancement. Let's... Oh, how do I change this? There we go. Reduce project context. Let's call it that. So you can have a conversation with the engineer, which has the project. So let's create a tiny brain here, or a tiny person. Let's see. Oh, your head is typically a bit smaller than your body. Let's give you a nice gray background here. And then you're gonna be a bit darker. Do we have? Okay, whatever. So this is a person, and inside this person's head, oh, come on, there's project context, right? Let's see if we can draw this a bit better. Project context. So this is very interesting to me, is that as engineers working on a code base, we have in our brains this project context. And when we get something like this, a user story like this, if we know the code base, we can immediately infer like, oh, we're using Firebase. We're going to use Google authentication with Firebase, for example. And I know that we already have task management. So it's only about like creating this Google authentication layer in front of it. I might also know that we already have authentication. We just don't have Google authentication. Like, I know all this stuff because I know the code base. And the question is, should we, with LLMs, should we make them know this? Should LLMs know about the code base? That would mean you would have to train it or fine tune it, or like it would have to have inherent knowledge about the code base. Is that the way to do it? I don't think so. I think they just need to, like, they maybe that's the way to do it, but it's more difficult because you would have to train your model on all changes to the code base. So it's not very accessible to do that. It's costly to do that, and the outcome is unknown. Like, it has all this information about this other code, and then you apply your specific code base to the training data. It doesn't mean that it has understanding of your actual code base. So I would rather think about these LLMs as someone who has never seen the project before, but he can learn about it incredibly efficiently. Or you don't think about the LLM at all. Yeah, okay. Let's explore this concept. So the way I think about this is we have this LLM and we have your code base. So let's create, I don't know, code. So should your code be inherent knowledge in the LLM? So that means training, fine tuning. Is this how you think about an LLM knowing about your code base? And I had like my reasons for thinking this is not a good idea. And that is costly. It's not very accessible, like in all kinds of things, in all kinds of versions. Like it's not accessible. If you compare inference, like just asking or prompting an LLM, that's something everyone can quite easily do using APIs. But training a model, that's way more complicated. Complicated, I guess, is the term I want to state. Unknown result. Let's call it non. Well, all result is non-deterministic. What should we call that? Very non-deterministic. As I said, like you're mixing your code base with a bunch of other code. So the LLM doesn't have an actual concept of your code base. It just has a lot of training data on your code. And the question is, how does it learn? Should you just give it all the files? Or should you give it like the full history of your project? So it doesn't only have all the current files, it also has like all the PRs created. What does it mean to actually learn your code base? Unknown. I'm noticing my brain isn't fully working today. I was up at like 3:30 last night. My 3-year-old woke up. Just completely messes me up. I need my sleep from 11 to 6 in the morning. If I wake up during that time, then it doesn't matter. Like my brain is fudge the next day. Really annoying. Unknown outcome. I'm just gonna put that for now. And then you can say, what was the other one? I had 3 ideas. I had 3 ideas. Okay, let's talk about the other one. So, should the code be on? Oh, sorry. Yeah. So, should the code be conversation? So, should the code be in the head of a person? Let's not call it code. Let's call it project context. That's better. Project context. Come on. Project context. Yeah. So should this be a conversation with an actual person who has the project context in their head and can explain to the LLM how to implement it? And this is how we think about one type of agent, right? Where it's very much up to it's more of a collaboration with an engineer. Like the engineer holds a lot of context about what needs to be done, and then the LLM can like help the engineer to do some coding. And the bad things about this is that, well, it's not autonomous. Not autonomous. Requires a senior engineer. So there has to be a person there who actually knows the code base quite deeply. Yeah, I'm not gonna make up 3 points just because I had 3 points. But then we have something else, which I believe is better, which is, it's basically RAG, but it's like autonomous retrieval. Let's call it retrieval, or let's call it RAG. It is RAG. So now you don't have a person there. You just have some kind of RAG. Let's just put a box. RAG tools. And the point is, we think about RAG as like a single thing often. Like you just have like one RAG box. You have one database with all the code, and then it just magically works. But I don't think that's true. So, but that's what we're going to discuss. Yeah, let's not make any. The point is, let's not even do that. So there are just 3 versions of this. It's like, okay, do training fine-tuning on the project context. And then there's an expectation that the LLM inherently just knows how to write the code, right? But there's a lot in the project context. So maybe we can discuss that first. What is a project context? We're reverse engineering this. What is a project context? A project context is the code, the actual code in the project, its dependencies, which means it's dependencies, versions, and documentation for that version. Its dependencies, specific versions, and documentation for that version. The Git history is the project context. Like, what do we know as engineers about the project context? That's what we're talking about here. And the interesting thing is that we have very much like lacking knowledge. And I'm excited to kind of dive into this discussion in terms of how do we retrieve information about the project context. Like, we don't know every single line of code. We don't know every dependency and version and how to use those dependencies, right? We don't know the full Git history. We have bits and pieces of it. And how do we as humans retrieve the knowledge required to actually execute on something as ambiguous as a user, I want to sign in with my Google account, blah, blah, blah. So we have the Git history. We don't have to say should we call it history? Yeah, let's call it history. It's not like technically the Git history that we have in our brains, but we know like how the project has changed over time. What we also know is what we have in our heads is the actual user experience. So we click around, like we're talking about web applications there, and we know how to interact with the application. That is part of our project context in our brains. So like we have a lot of how should I put this? Especially for us at Code Sandbox, like we use our product to build the product, so we use it all the time. So I have a shit ton of project context in my mind just by interacting with the product. Interactions with the product. The history of changes. That's what I wanted to say. We have interactions with the product. What other things do we have as project context that helps us resolve new user stories? Let's see. Specific version of documentation for that version. And my point is that we don't have the full context. We have bits and pieces. And this is where I think, okay, let's just put this here for now. So what I think project context is, as of now, I have to reflect some more, but it's the actual code in the project. It's the dependency, specific versions, and documentation for that version of the dependency. It's the history of changes, and it's interactions with the product. All of this is in our brains as engineers. The interesting thing is that it's not all of it. And that's what I find interesting about agents, is that they can know, so yeah, to put it in a different way, I, as an engineer, I have not actually looked at all the code in the project. I haven't looked at all the dependencies, their specific versions, and documentation for that version. I don't know the full history of changes. I don't know all the interactions with the product, but I know a lot, right? And this is what makes you an efficient engineer, is that you just have all this context that makes you very intuitively respond to suggestions for change. Now, the interesting thing about an agent is that they don't have any context, right? You have an LLM that's good at writing code generally, but it doesn't have any project context. But it's able to insanely quickly build up project context. Much, 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 much faster than we can as engineers. So you can imagine, as a human, joining a company as an engineer, you're asked to add, as a user, add Google authentication so I can see my tasks. That's what you're going to do. So for you to actually build up enough project context to figure that out, you have to go through a shit ton of code in the project. You have to figure out what dependencies are there. You have to read the documentation of those dependencies to figure out if Google Auth can be implemented with any of the existing dependencies. To gain the history of changes, you would have to go through the list of commits or a list of PRs, and you would have to play around with the product a lot to understand how it actually works. And that takes a long time, right? But the thing is, with an agent, they can do the same thing, but they can do it insanely quickly. And I think that's the power of AI. It's not that it's all knowing by default, it's that it can acquire knowledge much, much faster than a human being. It's a computer, right? Computers are if you want to do a math, solve an equation or something, a computer typically is much. This is a good analogy. So, this is very interesting. So I think I'm going to make a presentation out of this. So you're kind of just joining me here for some yeah, just having a conversation about AI. Let's see. So now the question is how, oh, this is going to be great. So how does human engineer, let's call it engineer. I hate calling it like human and AI as if uh, agent. So either that engineer is like a senior engineer. Yeah, okay. So senior engineer. So senior, I mean, who's worked at the company for like 4 years or something. And then we have junior engineer. I think that's the wrong term. But let's just use that terminology for now. So either you're a senior engineer, senior, senior, junior engineer, and then you have agent. Let's move this stuff around a little bit. Okay, agent. So the question is, how do you acquire this? How do you acquire this project context? Has fractions of code, depths, history, and interactions in their brains. Depths. And what's interesting, it's like you have a RAG process in your brain, right? Your brain is really good at, when you're given that prompt, right? Your brain does a RAG into its memory and extracts fractions of related information about that prompt based on all the experience you've had. It's very interesting. Needs to manually read code, docs, depths, docs, PRs, commits, and interact with product. And then an agent, how does an agent do this? It's basically RAG. So you have RAG for code RAG, depths plus docs RAG, PR, I guess you can call it like git history RAG. And the most difficult thing is interacting with the product. So that would have to be some kind of what is this? Like, how do you build up an understanding of how the product actually works in terms of interaction? So it would be like browsing. Well, let's just call it interaction RAG. Navigating through product, take images. So for every, that's the interesting thing. It's like the way that would have to, so code RAG is basically just take all the code files and put it into a vector database. And then you have the possibility to query that that database to get relevant. So you would basically just send the prompt of add Google authentication to see the tasks into your code RAG. It will extract relevant code and files for that. You would send the same prompt into your depths plus docs RAG, and it would give back what dependencies and documentation is related to implementing that. And then you can set it into the git history RAG, and it will send you git history back related to authentication and seeing the tasks and everything. And then you would send the same thing into your interaction RAG, and that would be a vector database of basically images and images and text descriptions of interacting with the product in some sense. But the point is, it can do this insanely quickly, right? So as opposed to the junior engineer, they basically do the same thing. It's just that the agent has these vector databases. It can ask, and it can ask about anything, right? So when you compare this agent to the senior engineer, they do have all the code, all the deps and docs, all the Git history, and all the possible interactions in the app through RAG. And they can take the prompt and just send it into these different sources of information and get back relevant information and build up their context, just like the senior engineer does with their own memory. But it's a fractured memory compared to like the full project context, because they haven't been part of everything, right? So this is what I mean. This is the power of an agent, is to use RAG. It's just that we're not ragging enough. Like I looked at this video from OpenDevin, and they don't use RAG at all. Currently they depend on the agent using the terminal and searching for contents in the code and everything, which works to some degree, but I don't think that is nearly enough. But I think this really shows my point. I have such a hard time like explaining all these concepts in my head. I think this helps. Okay, so now we talked about that. We can now talk about yeah. So let's put this above. Now we have this in here. I'd like to create these small lines. And then, okay, so I still want to start with this. As a user, I want to log in with my Google account and see my tasks. Yeah, this is going to be nice. And then we have this, and then we're going to see how yeah, now this was kind of weird. Let's do this again. So now we have, this is really the important point. So the point now is, okay, so let's take the question again. Make it, as user, I want to log in with my account. And then we want that prompt to be handled by an LLM, right? But the LLM doesn't come into play until we have done some things. So now we're going to do all of this. So now we're going to do all of these things. We're going to rag the hell out of this prompt. And then we're going to pass it to the LLM. So we have code rag, deps plus docs rag, git history rag, interaction rag. So what you actually send to the LLM here is, of course, not only this prompt, but you will get all, and this is the tricky thing, is like, we talked about how, where was this? How training fine-tuning has like an unknown outcome. RAG also has an unknown outcome. It's like non-deterministic. And of course, it depends heavily on the actual prompt. But what I think is, yeah, what do I think? So, yeah, what do I think? Anyways, so the point is that doing this, you're going to have a much better context for the LLM. Like, you're reducing ambiguity by using RAG, right? So you kind of wrap the project context around this prompt, and then you ask the LLM to do something, implement something, write code that implements this. And then you should get some outcome that makes more sense than just writing this. And I think the most important thing here is that you can actually test this. So you can start with a prompt. As a user, I want to log in with my Google account and see my tasks. Write the code for me. And then you can do that. And then you can implement CodeRag and you can ask the same question. How much better does it do? And then you can implement Deps and DocsRag. You can ask the question again. How well does it do? Then you can do Git history rag. You ask the question again. Does it do better now? And then you have the interaction rag. Ask the question again and then see how well it does. So that's also interesting about this. And what you can also do is you don't have to necessarily just do this prompt, do the rag, and tell the LLM to do something. You can ask it about validating that user story, right? Not just write the code and implement it, but validate the user story first. So this user story prompt, taking in all the project context, does this even make sense? And do you have any suggestions and so on? Let's see. But then it goes ahead and it actually implements something, right? So it goes ahead, creates output. Yeah, and what should it do? Sorry. Okay, so this is another part of it. Like, how does it actually produce the code output? Now it has a bunch of context. What it's fundamentally going to do is handle file system and write code. Some code might be updated in existing files. You might add files. It could even delete files if necessary based on the prompt. But it's basically going to do FS changes. Yeah, it's basically going to do file system changes. And the thing that's interesting about CodeRag is that even though you do get like the file and some snippet of code, you don't get all the code. And for an LLM to actually be able to as reliably as possible update code of a file, it should really read the contents of the file, so that it has the context of the file it's changing the code in. So it's gonna like read, write files. That's basically what it's gonna do. Read, write, delete files. That's what it's gonna do. And read, write, delete files. Yeah, read, write, delete files. That's what a code change is, right? And let's see. But now we get to the tricky part, which is, so this is just a change. And now let's make a curly arrow, because now we need to talk about validation. So validation. So now it has like, maybe as part of like doing this prompt, you've created like a branch. So it has like a sandbox environment in that sense. But then it's going to validate this implementation. And how does it do that? How does it do that? And you can talk about like how these agents can write tests and stuff, But I don't think, just like for humans, when you implement, like if you implement a pure function that's going to transform something, I think it's the story of testing is the same for agents as it is for normal engineers. So if you're working on the back end, you're writing pure functions, there's no UI, there's no state management. You just write this function and it needs to do something, and there can be like different results based on the input. So you can make an LLM, write a test for that, and then you can validate that the function was implemented correctly by running these tests. But in the context of web applications, unit testing doesn't make any sense unless you actually are some part of that implementation is pure functions. And I also want to argue like integration tests doesn't matter either, because it's just too complicated. It's too much state management. There's user experience, which is not captured by the integration tests. And it just takes a lot of time to make them work. You have asynchronicity, you need a lot of testing libraries. UIs and user experiences are iterated on a lot, as opposed to like having a transforming function on the server that typically sticks. So the code will change a lot, you'll be changing your files a lot. The best possible test you can do is to actually interact with the application. So that's what we're going to do. But to be able to interact with the application, it needs to actually run the application. So how would it actually run the application? And the way, you have to excuse me if I haven't zoomed in enough. So the way it would actually run the application, I'm going to check something, because if we jump back to this interaction rag, this interaction rag needs a tool. Like you can't give it the Chrome browser to do that. You don't have access to actually like navigating using an LLM and stuff like that. But there's something called Playwright, which is like one thing you could use to do this. But I am not quite sure how it works. Let's see. Because you install this thing. So the idea is that you actually, I wonder how do you run. So when you do Playwright, you point to a URL, right? Playwright test. By default, it will run in all three. From Playwright. Because you have to run the app, right? And then you run Playwright. Where you add configuration for play, including modifying which product you would like to run. If you're running tests inside now, check out running the example test. By default, we're in a blah blah blah. Shown in the terminal. Yeah, but how? Yeah, I guess I'm going to make that assumption. This is not about figuring out how to actually do it. So the point is that you have to give to be able to do. So let's look at this again. To do code drag, you have to give the code to the embedding API to produce vectors that can be later be used for retrieval. And the same is for, so it's a little bit more complicated with dependencies, because you need to find the docs for the specific version of the dependency, which we have been playing around with on the stream, using types of the dependency. You have the README typically, that also has some information. And then you have Git history rag, which you can generate by using Git, basically. And then you have interaction rag. And the way you would do that, as I see it, is that you would actually run your application, and then you would give an LLM access to the API of Playwright, for example. So the LLM would actually go in. Yeah, this is interesting. Yeah, anyways, so one option of that is, regardless, you have to give LLM access to the Playwright API, for example, through function calling. So the function calls would be like very specific APIs of Playwright, and you basically prompt it to go and navigate something in the application. And then as it's doing that, it will send information, some kind of information back. Maybe it should be images from the product. So every time it does like a click or something, it will then take a picture and that's sent back. And it would have to be like what button it clicked. Like this is definitely the most complicated thing. But the point is, when it's actually done implementing something, it can use the same mechanism to run the application and navigate through it and validate that it actually implemented it correctly. So it would you would run an LLM that has function calls to Playwright. It would use Playwright to go and navigate the application, take pictures, and evaluate if it was implemented correctly. That would be so much fun to work on, but it's definitely the most complicated thing. So what we're gonna say here is run dev server, run LLM with access to Playwright. Like it could be something else, but access to Playwright through function calls. Validate images, interactions against user story. Something like that. This needs to be in place to have like complete autonomous flow. The interesting thing though is that you don't have to do that to have an autonomous flow. So what you can do, you can like scope it down to not have validation. So the validation would be on some engineer. So the autonomous flow runs, does the implementation, and then lets you know when it's done implementing something, and then you jump into a preview and you actually test it. So that's fine. And I think that needs to be the way it works initially. And then when someone figures out how to actually do this autonomous validation, actually using the product, then you can make that part autonomous as well. Yes. But I guess this is kind of how I think about this. This is how I think about agents and how they should work. So to kind of summarize this, I'm going to make a video after this as I have it fresh in memory. But the point is that you have this thing you want to change in your product. And a user story is a really good way to describe that, because it says what do you want to implement and how is it going to work. Like it encapsulates both things. So you can use it for implementation and you can use it for validation. So it's just a good concept. So the point is, let's see if this makes sense. Yeah, is that to be able to prompt that and apply it to an existing project, you need project context. It's not enough with just a prompt. If you just send that prompt to an LLM, it can do any number of things. Maybe we can just try it for fun. Oh. Let's see. You have to excuse the size here. I can't change it. Maybe I can just use ChatGPT. I want to log in with my Google account and see my tasks. Please write me the code to achieve this. I know that. Yeah. Yeah, exactly. I didn't even know which language to use, right? But that is the whole point. Like, it's so ambiguous. It doesn't even know the language I would want to use. It says typically you use OAuth 2 flat. What the hell? Yeah. So it just uses dependencies that make sense, and it writes this out. And it only implemented like the backend part of this, which also makes sense. Like, it's ambiguous. But yeah. But then the question is, how would we make this less ambiguous? How would we provide the actual project context? So you could argue that you should train and fine-tune an LLM and embed the project context into its training data. And there's like challenges with that. Like, it's complicated. Like, the code base changes all the time, and it will be very expensive to do this training, and the data will be merged with all other details around its coding training data and similar like terminology and concepts from the project. So I don't think that's the way to do it. And then you could use an engineer which has a fractured project context in their head through a conversation to figure out how to do it. Or you can use RAG tools to do it. And what is actually a project context? And the way I see it, like through these initial reflections, is it's the actual code in the project. It's the dependencies of the project with their specific versions and documentation for using that specific dependency version. It's the history of changes in the project, and it's also interactions with the product. And as a senior engineer, you have fractions of code dependencies and how to use those dependencies. Let's do deps docs or deps plus docs. Dependencies and the documentation in your head. You have fractured history and interactions with the product in their brains. For a junior engineer who has never been exposed to any of this, needs to manually read code, find the dependencies, learn the documentation of those dependencies, or learn those dependencies. They need to look through a bunch of PRs and commits, and also interact a lot with the product to understand how it actually works. Now, the point is that an agent has the same starting point as a junior engineer, but they will way more efficiently retrieve information about the code, the depths, the history. Let's call it history RAG, and interactions RAG. Using RAG, right? So it's kind of like, and this should be better than even the senior engineer, because the agent has access to all the code, all the depths and documentation, all the history and all the interactions, as opposed to a senior engineer who relies on his or her experience and their like flawed human memory, flawed fractured human memory to interpret this. So an agent should be way more efficient at this. So how would this actually work? You would still have the prompt as a user, I want to log in with my Google account and see my tasks. And then you run that prompt through the different RAG tools to build up a similar context as an engineer already has by their experience working on the product. And as I stated, currently I reflect on like the code is important, the depths plus their docs is important, the history, history typically being Git history, but it could be PR history, doesn't matter. Well, matters, but not for just explaining what needs to be there. And then some interaction. And as I mentioned, you can like test how much better the LLM is at responding to this prompt, but like doing one at a time. Let's give it some code first. Let's give it what dependencies we have and the documentation for that dependency. Let's give it some history. Let's give it interaction. And then you have the LLM that will then go and read, write, and delete files. The agent will do that. And changes the code, and then it needs to validate by running a dev server. And the way it would need to actually validate a web application is to run an LLM with access to Playwright or some other tool through function calls, so it can actually open the page, interact with it, take pictures, look at HTML contents, whatever, and then validate those images and interactions against the user story. And this is by far the most complicated part. Yeah, it definitely is. But I think it's doable. People are playing around with this. I can't remember AI browser tool. Yeah, I can't remember. Browse AI. This is one of them. No, this is web scraping. I know there are people looking into this. Anyways, yeah, I think that's it. That's what I wanted to reflect on. Look at that. We actually got through it with my half-broken brain today. So what I'm gonna do now, I'm gonna make an actual video out of this, because this is like an ongoing discussions with colleagues. And what I would love to do is, what this also helped me realize is that I haven't been sure on how to approach, like, I think there is something to agents, autonomous agents. And there's a lot of complexity around like infrastructure and stuff, but that's interesting about Code Sandbox, because Code Sandbox has the perfect infrastructure to run autonomous agents. The question is just, how do you efficiently run? What does this autonomous agent actually look like? And what we can do here, we can just find a prompt. It could even be this prompt. And then we're gonna try to kind of, what's it called? Brute force some code rag, some depths, docs rag, history rag, and interaction, and maybe interaction rag. I don't know. As I said, yeah, we're gonna try some level of code rag, depths and docs rag, history rag, and interaction rag, like some level of it, and just see how it improves its understanding of how to deal with that prompt. That I think is a good project. And we can start with like something exceptionally simple. The point is that this super ambiguous prompt should suddenly now be quite non-ambiguous just by adding this rag information. Yeah, because I've kind of had this idea that no, there's no way you're going to go from this ambiguity to something it can implement without having a lot of interactions with it. But I've never thought about RAG as memory retrieval. It's like, as I said, it's kind of like your brain does RAG. The point is that this brain, it's almost like your project. I don't know. You kind of simulate this. Oh, we're gonna do this. Let's see. Where can we put that? So what's funny here is like you can actually think about this as a brain. And this brain has all code, all depth docs, all history, and all interactions. Project brain. So the project brain is like, let's see. The project brain is a vector DB or vector DBs. So the project brain is maybe we can put it in here. Oops. It's just a set of vector DBs for different kinds of information, for code, for deps and docs, and history and interactions. So you can retrieve everything, right? Not just fractures of your own experience. Now the question is like, how good are these RAG solutions? And they also are hurt by ambiguity, right? So the more concise you are with your prompt, the better the RAG will be as well. So there might be another level to this where you need to kind of reiterate the initial prompt to actually make it less ambiguous. But then you can use the same tool to make it less ambiguous. So you can like do multiple rounds of taking a prompt, using RAG to enhance it, to kind of state back to the engineer, is this what you're thinking about? Does this look great? And then when it's validated, it goes through and does it. Yeah, this is going to be fun. Anyways, I'm going to drop off and record this video, and then I'm going to jump back on because I have something else. I'm working on this project called Impact React, and React 19 is about to hit the stage. So I refactored a tiny pet project to use like the latest version of Impact and React 19 to see that it actually runs. So that's going to be nice to validate. Anyways, that's it for now, and we'll talk later, I guess. Bye-bye.